Hello all, good morning. So the course is Basic Electronics Engineering, the digital part. So myself, A. Venkat Subbareddy, Assistant Professor of Electronics and Communication Engineering at G. Pullareddy Engineering College. So in this session, I will discuss about the complement arithmetic. In the earlier video, I discussed about how to represent the binary numbers in different representation, that is signed number and the unsigned numbers. So based on that, I will discuss how I can perform complement arithmetic. Complements are used in the digital computers in order to simplify the subtraction operation and for the logical manipulations. So in order to simplify the hardware architecture for the subtraction and logical multiplication. So for each radix are represent base of the number system. There are two types of complements. One is radix complement and the another is diminished radix complement. So the radix complement is referred to as Or's complement. Diminished radix complement is called it as an R minus 1's complement. So for a binary system complements, so the base of the binary system is 2. So there are two types of complements for the binary number system are 2's complement, that is similar as an R's complement. So because R is equal to 2. So the R minus 1 is 1. So 1's complement. So the 2's complement and the 1's complements are the two complement methods in the binary system. So in the 1's complement of a number is found by changing all ones to zeros and all zeros to ones. This is taking complement or ones complement. So the example of ones complement, so the given number is 10101. So I can change all ones to zeros and all zeros to ones. So all ones to zeros. So 0, 1 is converted to 0, 0 is converted to 1, 1 converted 0, 0 to 1 and 1 to 0. So this is simple. Then second is 2's complement. So the 2's complement of a binary number is obtained by adding 1 at the LSB of 1's complement of the number. That is 2's complement is simply performed by using 1's complement plus 1. So this is the example. So 10101. So first convert into the or obtain the 1's complement, that is 1 to 0, then 0 to 1, 1 to 0, 0 to 1, then 1 to 0. Then add at the 1 at the LSB. So 0 plus 1, 1. So there are no any sub addition, so can copy it down the remaining bits. So this is 01011 is the 2's complement. So then how you can perform the subtraction by using the 2's complement. So with the help of subtraction by 2's complement method, we can easily subtract two binary numbers. The operation is carried out by means of the following steps. In the first step is at first obtain the 2's complement of the subtract end. Then it is added to the menu end. I will let you know what is subtract end and the menu end. Then if the final carry over of the sum is 1, it is dropped and the result is positive. So remember this. If the final carry of that sum is of the subtraction is 1, then it is simply dropped and the result is positive. If suppose there is no carry over after performing subtraction, so the 2's complement of the sum will be the result and it is negative. So that is after performing the subtraction. So whatever the result that we will get, we need to find out the 2's complement of that sum, then and that sum gives you the negative. So all these two we will know once if we perform the example. These are the 4 steps to be used in the subtraction of 2's complement. So the following examples on subtraction by 2's complement will make the procedure very simple and it is very clear. So these are the two numbers to be subtracted. One number is 110110 and another is 10110. This number we will call it as an addend and this we will call it as an subtractand. So the subtractand and the addend. So the solution, the first is the number of bits in the subtractand is 5 and while that of the minuend is minuend, not this is subtractand, addend, it is minuend. Subtractand is 5 bits, you can see here 5 bits and here are the 6 bits. So before performing the subtraction using 2's complement, first we can make sure that both the numbers have the same number of bits. So in order to make both the subtractand and the minuend with the same number of bits, whichever number is having less number of bits, we can add 0 to the left of that number. So that is, we make the number of bits in the subtractand is equal to that of the minuend by taking a 0 in the 6th place of the subtractand. So this number we can now write down it as an 0100110. So this is the given number. I have placed 1 at the leftmost position of that number, which does not change the given number. So now this subtractand become 6 bits. Now I can find out the 2's complement of this subtractand. So for that, first I need to get the 1's complement. So that is, the 1's complement of this is 101001. So that is 0 I can replace with 1, 1 I can replace with the 0. So this is 1's complement. I have written over here and I have added 1. So for this 1's complement I have to add 1, then I will get this 2's complement of this subtractand, that is 101010. Then after getting this 2's complement, add this value with the minuend. So that is, by using this 2's complement method, we are performing the subtraction by using addition. We are converting the subtraction into an addition in the complement methods, because this number is a positive number. So if I am complementing this subtractand, since it is in a positive number, if I am converting into the 2's, finding out the 2's complement, then it will become a negative number. So I am representing this positive number into negative number. So this sign of minus is included into the complementation. So we can perform directly addition. So the minuend is 110110 and the 2's complement of the subtractand is 101010. So after performing the addition, so I got total 7 bits. So 1, 2, 3, 4, 5, 6 and 7. So this 7th bit we will call it as a carry, because the given numbers are represented only 6 bits, but the result of the addition gives you the 7 bits. So this 7th bit we will call it as a carryover. So in any 2's complement method, if the addition gives you the carry, so then you can just simply ignore that carry. Whatever the bits left after ignoring this carry, so this will give you the subtraction of given two numbers. So after dropping the carry over, we get the result of subtraction is 1 0 0 0 0 0. This is how you can perform subtraction of two numbers using 2's complement. So in this case, the carry is generated. Then in the second, another example, we will see. So the given numbers are 1 0 1 1 0. Then another number is 1 1 0 1 0. So I can perform the same. First I need to find out the 2's complement of this. So before finding out the complement of subtract n, first I need to check both the numbers are represented with equal number of bits. So both the numbers are represented with 5 bits each. So there is no any additional bits to be added. So directly I can find out the 2's complement of subtract n, that is 1 1 0 1 0. So for that, first I can find out the 1's complement, that is 1. I can replace with 0 0 with 1. So it is 0 0 1 0 1 plus 1. So I can get 0 0 1 1 0. This is the subtractant represented in 2's complement. Then minuend is 1 0 1 1 0. The subtractant is 0 0 1 1 0. So I can simply perform the addition. So I got this result, that is 1 1 1 0 0. So you can observe in this case the sum is also 6 bits. So in this case no carry is generated. So if no carry generated, then the result of the subtraction is negative and is obtained by writing 2's complement of this result, that is 1 1 1 0 0. So if no carry is generated, so whatever the result that we will get, the result is negative. So how you can get the negative number is by complementing the result of this addition. We have to find out the 2's complement. So the 2's complement is again find out by using 1's complement plus 1. So 0 0 0 1 1 plus 1. So you will get it as an 0 0 1 0 0. So that is the difference is, so all these two bits you can neglect, the difference is 1 0 0. So before this number I have to put the negative if I convert into the decimal. This is subtraction by 2's complement. Then suppose if I have given the number including with the fractional parts, then the same, first I need to convert the 2's complement of these. This whatever we are performing previously, the same procedure to be followed. If it is 1, I have to replace with 0. If it is 0, I have to replace 1. And after that I have to add 1 to that 1's complement. I will get this 2's complement of this subtract n. So for that I have added with the minuend and the result is this one. Again you can observe both the numbers are having same number of bits and the result is also have the same number of bits, no extra bits. In this case also carry not generated. So then in that case the result of the subtraction is negative and you have to obtain the number by complementing the result. So that is I have to complement this, find out the 2's complement. So I will get this 0 0 1 1 1 dot 0 1. This is how I can perform subtraction of two given binary numbers in the 2's complement. Then similarly you can also perform subtraction by using 1's complement method. In subtraction by 1's complement, we subtract two binary numbers using carried by 1's complement. The steps to be followed in subtraction by 1's complement are, so first write down 1's complement of the subtractand, then to add this with the minuend. If the result of the addition has a carryover, then it is added to the LSB of the intermediate result to get the final result, and the result is positive. So this is the one point I need to remember. Then the another is, if there is no carryover, so then 1's complement of the result of addition is obtained to get the final result, and that number is negative. So this is another point need to remember. In the 1's complement method, if the carry is generated after the addition, so that carry need to be added to the LSB of the intermediate result to get the final result, and that result is positive. If there is no carryover, then 1's complement of the result of the addition is obtained to get the final result. So if there is no carry, first we have obtained the 1's complement of the result whichever we got, then the result is negative. We will see one by one. So the 1's complement of this subtractand is, so by complementing the bits, again before performing this I have to verify both the numbers have the same number of bits. So it is having 6, minuend having 6 bits, and subtractand is also having the 6 bits. So both the numbers have the same number of bits. So I can directly 1's complement of, sorry, 1 0 1. So 1 0 1 0 1. So the 1's complement is 0 1 1 0 1 0. So I have to replace ones with the zeros and zeros with the ones. Then I had to perform the addition of both the minuend and the 1's complement of the subtractand. So I got this result. So you can observe both the numbers are represented with the 6 bits and the result is having 7 bits. So that is, it has generated one carry. So that one carry I can add to the LSB. So after that, whatever the result that I will get, so that gives you the subtraction of these two given binary numbers. The required difference is 1 0 0 0 0. So this is how you can perform when the carry is generated. Then similarly, another example is, the numbers are 1 0 1 0 1 1 minus 1 1 1 0 0 1. Again, first I need to verify both the numbers are represented with same number of bits, that is 6. So I can directly find out the 1's complement of the subtractand, that is 1 1 1 0 0 1 is equal to 0 0 0 1 1 0 in the 1's complement. So after that I have to perform subtraction. After performing the addition of minuend, 1's complement of the subtractand, I got the result as 1 1 0 0 0 1. So you can observe the result is also having the 6 bits. So no carry is generated. So if there is no carry over, the result of the subtraction is, first it is negative. Then how I can obtain the negative number? By writing the 1's complement of this result, that is 1 1 0 0 0 1. That is, I can write down 1's complement of this 0 0 1 1 1 0. This is how you can perform the subtraction using 1's complement if no carry generated. This is another example including with the decimal points. So again you can observe both these fractional part and these integer part, both are represented with equal number of bits. So you can observe the here the integer part is represented 4 bits and the fractional part is 3 bits. Then you can observe here integer part is with the 3 bits and the fractional part is 2 bits. So before converting this to ones complement, so first I need to convert this integer part into 4 bits, that is 0 1 1 0. So that is this integer part I have to add the 0 or the leftmost, and for this fractional part here it is 3 bits, here it is 2 bits, so 1 0. Then I have to write down 0 on the rightmost side of that fractional part. So this is the basic difference when we are subtracting two when subtracting two numbers with including fractional parts. If they are having a different bits in the integer part and the fractional part, so you have to add zeros accordingly. And now for this you have to find out the ones complement, then perform the subtraction minuend, then ones complement or subtract n. So I have to subtract, then I got this result. So total how many bits are used? Total 7 bits are used. After subtracting this, so I got total 8 bits. That means this extra bit I have to add at the LSB. So it will gives you the 0100.101. So this is the difference of these two numbers. Thank you.